Hi guys, welcome back to SuperMath4U. This is Mr. Urrego, and today we're going to work on inverse trigonometric functions. We have y equals sine of theta. This is my regular function. Okay, I give you an angle and you find the sine of that angle. Therefore, you're going to give me a ratio. Okay, 1 square root 2 over 2. Give me a ratio, a number. When we do an inverse, I'm asking for the angle. What's the measure of the angle? And for that, we use inverse function, sine to -1 of my ratio. Okay, so what I got here, 1 square root 2 over 2, or square root 3 over 2, or 1/2, whatever ratio I have here, then it's going to go here. And that's what I'll be using, sine inverse, right? That's the inverse function. Another way of writing an inverse function is doing arc sine. Arc sine is the same thing as sine to a -1. Right? Inverse of sine. Or cosine, cosine -1. So either one of them is the same thing. Let's start. When we're talking about inverse function, there's one thing that we need to satisfy, and the function has to be a one-to-one function. In order to be a one-to-one function, the graph had to satisfy the vertical line test, right? I'm touching only one point. Let's pretend that these are vertical lines, pretending. Okay, come on, stay with me. Vertical lines. If I touch only one point, then they pass the vertical line. Therefore, this graph is a function. Okay, but now we talk about one-to-one function. To satisfy a one-to-one function, this graph also has to satisfy the horizontal line test, right? If you notice, I'm touching my graph multiple times. If I touch it more than one, then it doesn't pass the horizontal line test. Therefore, it's not a one-to-one function. So, because the whole graph doesn't satisfy this, then what I'm going to do is I'm going to restrict the domain. Right now, the domain of this function is all real. I'm going to take only a piece of my graph. I'm going to start here, and I'm going to take this piece that I'm turning in red all the way to pi over 2. And that's this piece. Now, on this piece of graph, is that a function? Yes, it passes the vertical line test. Is that does it pass the horizontal line test? Yes, it does. So this is a one-to-one function. So this piece from the sine function, I'm able to use it as my inverse of sine. Okay, so that's the whole idea. Now, having this, what I'm going to do is I'm going to find the inverse of this function. This graph that I just showed you here, this diagonal line, this line is y equals x. So every time I'm doing an inverse function, I'm going to reflect my graph over this line. So whatever is on the top is going to be reflected on the bottom. And whatever is here on the bottom will be reflected on the top. Like that. So now what I just did here, this is going to be the inverse function. So now that's my inverse function, which is going to have here on the right side. Okay, so now this is the inverse function. As soon as I reflect this over the line y equals x, what I'm doing is I'm flipping the x and the y. So what used to be the x, now it becomes the y, right? The values, remember the values, they used to be an angle, pi over 2 pi, right? Now that becomes the y. And because the piece that I'm using for is from -pi over 2 to pi over 2, so that's what I have, -pi over 2 to pi over 2. So what used to be my domain becomes my range now. And what used to be my range, which is -1 to 1, now becomes my domain. So this is the inverse function, and this is what I'm going to be using. Now, there's a relationship between this and the unit circle, because if you notice, I'm using from -pi over 2 to pi over 2. We're bringing the unit circle from -pi over 2 to pi over 2. -pi over 2. Remember, I go backwards. So this is -pi over 2 all the way to pi over 2. So this is where I can use my inverse function. I'm not able to use it on Q2 and Q3, only in Q1 and Q4. So that cannot use. Having said that, this is the most important part of the whole deal. From -pi over 2 to pi over 2, that's where my inverse is going to be defined. So now let's practice. Remember, I'm not able to use any of this. That doesn't mean I cannot use the angle itself. So on a regular basis, I can ask you, how much is the sine of, let's say, pi over 4? So what do? You go to the unit circle, and you go to where the pi over 4 is, and because I'm looking for the sine, then you know that is the y value. So my answer here is square root 2 over 2. Alright, remember, this is the sine, and the x is the cosine. X is the cosine, my y is the sine. Nice. But what about if I go inverse? So right now I give you the angle and ask you for the ratio. What about if I say, hold on, let me find the inverse function of square root 2 over 2. So now I'm giving you the ratio, I'm asking you for the angle. Every time I use the inverse function, the question is, find the angle, right? The angle theta. So what you do is, alright, so the question is, what is my angle when my sine is square root 2 over 2? So I go to square root 2 over 2 and I go and search for the angle. So my answer here is pi over 4. So this is my regular function, this is my inverse function. I'm going backwards. One more. This is that I give you guys on a regular basis. Well, how much is the sine of 30 degrees? I can give you in radians or I can give you in degrees. You go to the unit circle. 30 degrees sine is 1/2. My answer is 1/2. But what about if I ask you the opposite? Give me the angle where my sine is 1/2. So what do? You go, oh, my sine here is 1/2. What is the angle? 30 degrees. My angle is 30 degrees if they ask you in degrees. If not, it's going to be pi over 6. So I hope you understand the idea that the inverse function is asking you for the angle. That's the whole thing. Now, let's recap something, right? How much is the sine of 5 pi over 6, right? I'm giving you this one. How much is the sine of pi over 6? What's the answer? 1/2. Excellent. But if I ask you, give me the angle where my sine is 1/2. Remember, are you going to give me 5 pi over 6? Is the angle 5 pi over 6? No, because remember, your inverse function only goes from negative pi over 2 all the way to pi over 2. Remember, Q2 and Q3 are not valid. They're not part of my range. Okay, so therefore you cannot use them. So if I ask you, how much is the angle where my inverse function is 1/2? You have to go straight to either Q1 or Q4 and find out when the sine is 1/2. Here is negative, here's positive. Therefore my answer is 30 degrees or pi over 6. So this is where the magic happens. Okay, so this is where people get confused the most. Let's do another one. Find the sine of 4 pi over 3, right? This is my angle. Remember, this is the regular question. So the answer would be, I go here, 4 pi over 3. And my answer is negative square root 3 over 2. Okay, so every time I'm asking you for a ratio, you can use the whole unit circle. But if I ask you for the inverse function, here comes the problem. So if I ask you, give me the angle when my sine is negative square root 3 over 2. Can I go on this quadrant? No, you cannot. So you got to use either Q1 or Q4 and find out when your sine is negative square root 3 over 2, which it's here. Okay, so what's my answer? Remember, I can't go through here. I cannot go through all this Q2 and Q3. You can't. Alright, so necessarily this is out of the window. You can't use these quadrants. So you have to give me a positive angle or you have to give me a negative angle. So the question is, give me the sine when give me the angle when the sine is negative square root 3 over 2. Then you see it here. This is, hold on, how much is the angle? Can I go through all this? No, you got to go backwards. And I see this and my angle is right here. Okay, so what's the answer? 300? No, remember we're going negative. So if the whole circle is 360 and this is 300, then that means this angle from here to here is 60 degrees. So my answer is negative 60 degrees. Why negative? Because I'm going this way. Alright? Or if this is pi over 3 and I'm going negative, then the whole thing, this is 3 on the top and 3 on the bottom, the whole thing is 6 pi over 3. So this reference angle is pi over 3, but because I'm going negative, it's going to be negative pi over 3. Let's do one more of this. If I give you y equals, let's do 2 pi over 3. Find the sine of 2 pi over 3. Okay? The answer, again, this is a regular function, is not an inverse function. So my answer is simple. 3 over 2. Things happen is, or things change if I ask you for the inverse of square root 3 over 2. Remember, if you're using the inverse, I'm asking for the angle. So can I give this angle? No, because remember, Q2 is not part of my answer. So I gotta find out in between Q1 and Q4 where my sine is this. So I go to Q1, 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 and I find it here. This is alright. So sine inverse of that is gonna be 60 or pi over 3. So my angle is either 60 degrees or pi over 3. Let's do cosine. Same idea with the cosine, right? It passes the vertical line test, but it doesn't pass the horizontal line test. Therefore, I have to take a piece of it, all right? In my case, I'm going to start here, so which is the same as from here all the way to here, because as soon as I keep going up, now it's not going to pass the horizontal line test. So I'm going to take only that piece. And that piece goes from 0 all the way to pi, if you notice, right? All the way to pi. Then I do the same thing. I flip it over the line, right? Diagonal line. Diagonal line. What's on the top goes on the bottom, and what's on the bottom goes on the top. And this is going to be my inverse function. So this is my inverse. Same idea with the unit circle. Now I'm going from 0 to pi. That's the restriction for the inverse cosine. From 0 to pi. From 0 all the way to pi. So my cosine, I'm not going to use Q3 or Q4. I only use Q1 and Q2. Same idea as the sine. Let's go straight to the hard ones. Okay, I'm asking you, cosine of 4 pi over 3. Remember, this is not the inverse, so I'm asking you for a ratio. So you go, this is alright, great. 4 pi over 3, this is 4 pi over 3. My cosine is the first value, so my answer is negative 1/2. But if I ask you for the inverse, cosine inverse of negative 1/2, then remember, you cannot use Q2, Q3 or Q4. So you have to search for this value either on Q1 and Q2. And because it's negative, you know that the x is negative on Q2, so negative 1/2, negative 1/2. Here's negative 1/2. What is the angle? 2 pi over 3. So y, my angle, where the cosine is negative 1/2 is 2 pi over 3 or 120 degrees. Let's do one more. Let's say that I ask you, give me cosine of something over here. 5 pi over 3. 5 pi over 3. This is your regular function. This is alright. 5 pi over 3 is my regular function. My cosine is the first value, 1/2. So if I ask you, how much is the cosine inverse of 1/2, then you gotta go here, Q1 or Q2, 1/2 cosine, here we go. If you notice, something that you have to notice is, if it's in Q4, then it will move to Q1. If it's in Q3, it will move up, straight up, okay? So what's gonna happen? Whatever angle is here, it will move to Q2. If the angle is here, it will move to Q1. So in my case, because the cosine inverse of 1/2, then straight up, cosine inverse of 1/2, and the angle is 60. or pi over 3 radians. Okay? Same thing happens with the sine. If the original angle was here, then it will move to the right straight up. You see that? Here, straight to the right. And if there's something here, because we're doing sine, look, the sine is the same thing, so we move to the right. If it's square root of 2, negative square root of 2, then it will be here to the right. Okay, so if it's located in this quadrant, it will move to Q2. If it's located in this quadrant, it will move to quadrant 1. That's a quick trick, about the unit circle. Okay, that's it for today, guys. Thank you for watching. Please like the video, subscribe to the channel, hit the notification bells, and I'll see you in the next one. Take care. Bye-bye.